Hello, we are discussing about GATE 2014 ECE paper, and this question is related to digital circuits. For a given sample and whole circuit, if the value of the whole capacitor is increased, what happens to droop rate and activation time, whether they increase or decrease? That is what the question asked. Okay, so first we will see about a simple sample and whole circuit, and we will see about its operation. Then we will see what is meant by activation time and droop rate. From that one we are going to finalize the answer for this one. Okay, so look at this circuit. This is a simple sample and hold circuit. Assume initially capacitor is uncharged. This is C hold. The capacitor assume initially. Okay, assume initially capacitor is uncharged. Capacitor is uncharged. That implies nothing but voltage across the capacitor is 0. Okay, so that is initially voltage across the capacitor is 0 volts, and the pi clock pulse when pi clock is equal to 1, then the MOS transistor is in on condition, so that it goes into on condition. By that time this is acting as a short circuit, so that act as short circuit. Whenever it is acting as short circuit, now capacitor is connecting towards input signal, so V capacitor, voltage across capacitor, is now equal to V input ideally. Okay, ideally it is going to be connected to input voltage, so capacitor charges to the input voltage at that instant of time. That is what ideally happens when again Q clock is going to become 0. At that time the MOS transistor is going to be now in the off condition. Whenever it is in the off condition, it acts as open circuit, so there is no relation between the input voltage and capacitor voltage right now. Excuse me, because the MOS transistor is going to be acting as off, in the off condition it is acting as open circuit. So now capacitor is going to be holds the value it has stored. Capacitor holds the value. Okay, so what was it has charged previously, that will be held by the capacitor. That is what ideal sample and hold circuit. That is nothing but this is the waveforms corresponding to ideal sample and hold circuit. Ideally we are going with a clock pulse is going to be generated over here. Ideally the clock pulse is going to be generated in this way. This is time and this is pi clock, and it will be generated after every t seconds. It will be generated an impulse. So an impulse is going to be generated. Impulse is present only at that instant of time, and during that time the MOS transistor is going to be in the on condition. By that time the capacitor stores the input voltage at that instant of time, and afterwards again the transistor acts as off switch. Then the capacitor holds the charge what it has charged. So look at this one. So this is, let us assume for the first time the capacitor is going, that MOS transistor is coming into on condition. By that time the voltage present over here is this one. This is the voltage present at that instant of time. This is input signal, and for this input signal this is the voltage present at that instant of time when pi clock is going to be 1. So by that time the voltage is nothing but this is the voltage you are going to be, this is capacitor stores the same voltage. For example, if it is 2 volts, at that time capacitor also stores towards 2 volts. Later this voltage is going to be gets hold. Now after that one, this capacitor, now the MOS transistor is going to be in the off condition during this 2 pulses. In meanwhile again the MOS transistor is in the off condition. By that time capacitor has to hold the same value till the next pulse is going to be appearing. Then again whenever pi clock is equal to 1, again the MOS transistor comes into on condition, so that it will be charging towards the new value of input. So charging towards new value of input is nothing but you are taking a sampling. That is nothing but you are taking a sample of input signal, or you are capturing input signal at that instant of time. That is what called as sample. So capturing the input signal at the time of MOS transistor is on. By that time it is called as sampling mode. This is going to be treated as sampling mode. And whenever the mass transistor is in the off condition, the capacitor is going to be holding the previously stored charge. So this is going to be called as holding mode. So sample and hold circuit will be consisting of two important modes. One is sampling mode, the other is nothing but holding mode. Okay, during sampling mode, capacitor is going to be taking sample of input signal, that is capturing the input signal at that instant of time, and after that one the capacitor holds that charge, okay, until the next pulse is going to be appeared, such that the transistor is again going into the on condition, so that it can take the next sample of the input signal. Okay, so now this is what we are interested in. This is C hold, that is nothing but hold capacitor. Since during hold operation, holding mode, the capacitor has to hold the charge stored in this one, so that's why the name has come C hold, that is nothing but hold capacitor. If you increase the hold capacitor value, what happens to acquisition time, what happens to droop rate? Okay, so first of all, this is what the ideal sampling and hold circuit, but practically what happens is nothing but, practically capacitor cannot charge instantaneously. Capacitor definitely it requires some time, and capacitor charges with respect to some time constant. The time constant is nothing but, okay, resistance of mass switch. So definitely within no time the capacitor is charging to input voltage, that is what we are expected, but this doesn't take, okay, within no time capacitor doesn't charge towards the input value, it takes some time. That time is going to be called as acquisition time. That time is called as acquisition time. So acquisition time acquisition time is nothing but, this is the time required for the capacitor to charge to the full value, that is nothing but to charge to the input signal value, and to remain within a specified error. If it is not exact at that time, there will be some small error, and that is nothing but specified error bounded around the final value. So that much time it requires, that is called as acquisition time. Acquisition time is the time required for the capacitor, that is nothing but for the hold capacitor to charge to the input signal, and to remain within a specified error bound within the specified error band around the final value. Okay, so let us assume if you are going with, so let us assume here input signal is 2 volts, but the capacitor may not take 2 volts at that instant of time, so it takes some time. After that one it is going to around 1.9 volts. So the error is nothing but 2 minus 1.9, which is nothing but 0.1 volts. So is this difference is going to be whether it is specified bound or not, that you have to check. So this must be, the capacitor has to charge such that it will be around the final value with specified error band around the final value, so that is will be treated as a sample signal. So acquisition time is the time required for the hold capacitor to charge to the input signal applied, and to remain, if not final value, at least it has to remain within a specified error band around the final value. And acquisition time is mainly a function of capacitor charging currents, time constants of the charging circuit, and slew rates of the buffers used. Okay, acquisition time is mainly function of capacitor charging currents, time constants of the charging circuit, and slew rates of the buffers involved in the circuit. So here if you are going with, as holding capacitor value is going to be increases at that time, time constant for the charging is going to be increases. Whenever time constant for the charging increases, at that time the capacitor takes longer time to charge towards the given value, so that acquisition time is going to be increases. You must apply more time, you must give more time for the capacitor to charge to the final value, so acquisition time is going to be increases. Acquisition time increases as hold capacitor increases, charging time constant increases, so that acquisition time also increases. So now we are coming for the droop rate. Second important is nothing but droop rate. Droop rate. This droop rate is going to be called as, droop rate is the change in the output voltage per unit of time. while the sample and hold circuit is in the hold mode. So what we can say is nothing but ideally whenever it is in the hold mode, ideally the capacitor voltage should not decrease. Okay, so the capacitor should not discharge charge present in that one ideally, but actually what happens as time progresses it discharges. So how much it is going to be discharging with respect to time is called as droop rate. Droop rate is the change in the output voltage per unit of time while the sample and hold circuit is in the hold mode, because in the hold mode only capacitor has to held constant. The value present in the capacitor should not discharge, but practically it discharges. At what rate it is discharging is specified by the droop rate. Droop rate mainly originates because of leakage from the hold capacitor, and this leakage major contributes for this leakage currents are nothing but switch leakage currents as well as bias currents. And droop rate is going to be given by the equation dV out by dt. Units for this one is nothing but volts per second. Volts per second is nothing but units, and droop rate is going to be defined as dV out by dt, or it is also defined as IL divided by CH. That is nothing but load current divided by leakage current. IL is nothing but leakage current divided by hold capacitor value. Leakage currents are going to be in the range of picoamperes, and hold capacitor is also in the range of picofarads. So this is what droop rate is defined as. So from this equation we can say as hold capacitor value is going to be increases, at that time CH increases, that is droop rate. So droop rate is going to be as CH increases, droop rate decreases. Okay, as capacitance increases, at that time time constant is going to be increases. Whenever time constant is increases, at that time discharging rate reduces, so that droop rate is going to be reduces. So as hold capacitor increases, we can say acquisition time increases and droop rate reduces. This is what our correct answer. Now we will see about the correct answer. For a given sample and hold circuit, if the value of the hold capacitor is increased, then droop rate decreases and acquisition time increases. The right answer is nothing but B. Right answer is B for this one. Thank you.